Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. This is going to be a session where we record the answers to the revision pack for the grade 11 exam unit 7.1 to 7.4. So what I'm going to do is I'm going to answer the questions in the revision pack. As always, please try and answer the questions before I answer them myself. Okay, so this is what I'm planning on doing, is I'm going to be answering these questions. It's going to be a slightly longer session because I'm going to be doing all four, 7.1, 7.2, 7.3, and 7.4. And then after that, I've got some questions and answers as well in multiple choice and conceptual and calculation form. So, and then what I'm planning on doing is compiling everything in one mega video revision. Okay, so let's go. I don't want to waste any more of your time. Right, we are going to be answering these first. So first and foremost, just give me a second, sorry, while I set myself up. Here we go. We've got a question here that says mass and speed data for 4 objects are given below. Rank the objects in order of increasing magnitude of momentum. Indicate ties where appropriate. So in order to answer this question, we need to recognize that, obviously, here it is, question 1. We need to recognize that momentum equals mass times velocity. And once we understand that, and we know that that there is mass, and that there is velocity, or speed in this case, then we can answer the question. And so, I know, I'm just going to do this instead. I'm just going to add momentum over here. And so 1 times 1 equals, oh, why did my video suddenly stop? Just a second, let me try and fix this. Okay, and we're back, magic. So as I said, what I'm going to do is I'm going to put momentum down here, and then so 1 times 1 equals 1. Oh, and we're off again. Why does it keep doing that? Is it going to work this time? We'll see. 1 times 1 equals 1. 2 times 3 equals 6. 0.1 times 2 times 20 equals 2. And 5 times 0.2 equals 1. Okay. So which one is the most? Indicate rank in order of increasing momentum, increasing magnitude. So be careful with that in the exam. Increasing means you start with the lowest. Okay. So obviously 1 times 1 equals 1, but also 5 times 0.2 equals 1. So both of these, so the rank would look like this. A, D, followed by C, followed by B. Okay, let's go to question 2. Question 2 says, soccer player 1 has a mass of 45 kilograms and moves to the right with a speed of 1.4. So here we go, here's soccer player 1. Okay, and he is moving to the right with a speed of 1.4 meters per second, and his mass is 45 kg. And we've got, what else do we have? Soccer player 2 has a mass of 32 and moves to the left. So soccer player 2 has a mass of 32 kg and moves to the left with a speed of 2.1 meters per second. I'm using, sorry, I am using a new tablet to write with, and it just takes a little bit of getting used to. So please bear with me. I'm trying very hard. I might have to get rid of that. Let me just write meters per second here, and then I'll put the 32 kilos here. Okay, so what is the question? The question is asking, what is the direction and magnitude of the total momentum of the 2 players? So first of all, we have to work out the momentum, and of course momentum equals mass times velocity. So for the first player, it's going to be 45 times 1.4. And where's my calculator when I need it? I probably have it here. Always have an extra calculator. I've got 3 or 4. Make sure you get enough calculators. You should at least have 2 calculators for the exam, okay? Just in case one of them starts acting up. So let's have a look. 1.4 times 45. So the momentum for that one is going to be 63 kg dot meters per second. And the momentum for that one is going to be P equals m times v. Now, I just want you to be careful with one thing here. They are going opposite directions, so I'm just going to give this a negative sign. I don't have to give this a negative sign. I can give this one a negative sign. It's just that they have to be opposite to each other, right? Because they are going opposite to each other. So this one's going to be 32, and that one's going to be minus 2.1. And that would give me 32 times negative 2.1, and that's going to be negative 67.2. And so the overall momentum, what is the direction and the magnitude of the total momentum? What are the direction and the magnitude? The magnitude is going to be 63 plus that. So the magnitude of the total momentum is going to be negative 4.2 kg dot meters per second. Okay, alternatively, let's say for example, I did it the other way around, minus 63 plus 67.2. It will give me 4.2 instead of negative 4.2. So what does that mean? It just means the direction's changed, all right? So this is negative 4.2, and it's headed to this way, right? So because it's negative, I don't actually have to say it's this way. But if I had positive, I would say it's to the left. So the answer is 4.2 kg dot meters per second to the left, or negative 4.2 kilograms dot meters per second. And as long as you know, as long as you show here that this is to the left is negative, and then it'll be fine. Okay, I'm gonna have to get rid of some of this stuff. Can I do that in one swoop? Screen, black screen, nope. Pointer options, erase all on, yep, perfect. So I'm going to go to question 3 now. Two carts move directly towards one another on an air track. Cart 1 has a mass of 0.35 kilograms. So this is cart 1. The mass is equivalent to 0.35 kg. And the speed is 1.2. So 1.2 meters per second. And we've got cart 2, so this is cart 1. And we've got cart 2, and that one has a mass of 0.61 kg and a velocity of, what speed must cart 2 have? Okay, so we don't know. So that's what we're trying to do. Okay, so in order for the total momentum to be 0, then cart 1, momentum of cart 1 has to equal momentum of cart 2. So P of 1 has to equal the momentum of 2 in order for the total momentum of the system to be 0, because they are opposites to each other. This one's moving this way and that one's moving this way. So I can tell you right now, just by approximating, that the velocity of cart 2 has, because that's double the mass, approximately double the mass, that has to be about half the velocity in the opposite direction. So if I get about negative 0.52, negative 0.55, that's about the right answer. So straight away, I'm just going to write that over here. So negative 0.5 thereabouts, between negative 0.5 and negative 0.6, then I'll know I got the right answer. But that's just something for the side here. So I have to work out the momentum of cart 1, which is 0.35 multiplied by 1.2, which is 0.42 kg dot meters per second. That is what the momentum of cart 1 is. It's just simply mass times velocity. Okay, so momentum equals mass times velocity. I just multiplied the mass by the velocity, and that gave me 0.42. Now I know that that has to be the same in order to cancel out. So now I have the momentum. So 0.42 equals 0.61 times something. Now the only thing I have to remember is, of course, the momentum in this case will have to be opposite to the momentum in that case because they are opposite to each other. So it's negative 4.42 divided by 0.61, and that's going to be minus 0.69. More or less within the range of what I expected, which is minus 0.5 to minus 0.6. So that is correct. Okay, so in order for the system to have a momentum of 0, the speed of COT2 has to be negative 0.69. Okay, and that's how you do that one. Let's do question 3. I have to once again get rid of this. Pointer, erase all ink on, yeah. Okay, question 4. Just a second. Okay, so question 4, here we go. A 26 kilogram dog is running northwards at, so here we go, he's running north. There's the dog. The mass is equal to 26 kg. The speed is, or the velocity is 2.7 meters per second. And we've got a 5.3 kilogram cat running eastwards at 3 meters per second. Oh, it's so hard to write on this new tablet. The mass of the cat is 5.3 kilos. Okay, what are they trying to find? The magnitude and the direction of the total momentum for the system, right? So basically in this case, I have to find the momentums for each. So once again, it's P equals mv. So for the first one, for the dog, it's going to be 2.7 times 26, 2.7 times 26, which is 70.2 kg dot meters per second. That's momentum of dog. And then momentum of cat is going to be P cat, which is going to be 3 times 5.3, which is 15.9. But we're not done. And we can't just simply add them because they're not on the same plane. So don't make the mistake of just simply adding them, because one of them is pointed this way and the other one's pointed this way. So what do we do? What we do is we actually make a triangle. So the triangle is going to be such that this is 70.2. Don't